Alina has 12 blocks, 2 of each of red, blue, yellow, green, orange, and purple. Call an arrangement of the blocks even if there is an even number of blocks between each pair of blocks of the same color. For example, the arrangement RBBY, GGYR, OPPO is even. Alina arranges her blocks in a row in random order. The probability that her arrangement is even is m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, so we have 12 blocks, two of each kind for 6 different kinds. And you're going to arrange them. And you want to find the probability that, let's say, the 2 red blocks are have an even number of blocks between them, and the 2 orange blocks have an even number of orange blocks in between them. And so what I'm going to do is I'm actually going to draw 12 slots for these 12 blocks. 7, 8, 9, 10, 11, 12, and I'm going to number them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And right now what I'm going to do is I'm just going to play around with a few examples of what it means to be even. So let's say I'm trying to place my 2 red blocks, and I'll use a red color for it. And let's say, so I place my red block here and my red block here. Right away, I know I've made a mistake, because let's count the number of blocks between them. 1, 2, 3. You have an odd number of blocks between the 2 R's, 3 of them. So the 2 R's can't go on 4 and 8. So let me just make a little bit of a table to illustrate what even and odd is. So you have 4 and 8 are in the odd column. Now let's try a different example. What happens if I place my reds here? I'm just going to choose 2 random spots, 3 and 9. Well, how many blocks are between those 2 reds? 1, 2, 3, 4, 5. That's an odd number. So once again, you see that 3 and 9, you can't put the reds there. Let's try one more example. What if R is here and R is here? How many blocks are between them? 1, 2, 3, 4. 4 blocks. So you can see that in this arrangement, there are an even number of blocks between the 2 R's. So 4 and 9 goes in this column. And similarly, let me draw out a few more examples. Having 2 reds next to each other, 5 and 6. Is even because there are no blocks between them. You could have the blocks between 1 and 12 where everything is between them. There are 10 blocks between them. So 1 and 12 also work. And if you look at this table, you can kind of see a pattern here. Look, every time 2 blocks have an even number of blocks between them, one of them is on an even number slot and the other is on an odd number slot. So you see the 4 is even, the 9 is odd, 5 is odd, 6 is even, 1 is odd, 12 is even. Every time you have an odd number of blocks between the 2 same colored blocks, you either have 2 evens or 2 odds that the 2 red blocks are on. So what do we want? We just want the probability that her arrangement is even. Her arrangement is even. So what does that mean? It means that for every single color, 1 block is on an even numbered slot and the other block is on an odd numbered slot. Then no matter what we do, it works. Like let's say I put my greens on 2 and 5. Let's say I put my purples on, give me an even number, let's say 8 and 3. If my yellows are on block 12, block 1, let's say my reds are on blocks 10 and 11. My blues, let's say they're on blocks 6 and 9. Let's say my oranges are on blocks 4 and 7. Then you can see that for every color, you have an even number of blocks between them because one of them is on an even numbered slot and one of them is on an odd numbered slot. And we want to find the probability that this is the case. So now that we've now that we've made this a little bit easier, let's go ahead and actually calculate the probability. So remember, probability in every case was what we want over what could possibly happen, total number of possibilities. And it's easier for us to calculate the total number of possibilities because, well, how many ways are there to arrange two R's, two B's, two Y's, two G's, two O's, and two P's in a line? Well, if all 12 of those letters were different, you'd have 12 factorial, but some of those letters are the same. You have to divide by 2 because the two R's, you can't differentiate between them. So like for example, if this one's an R and this one's a K, that's different from if this one's a K and this one's an R, but obviously neither of them's a K, so you can't differentiate them. They're indistinguishable, so you have to divide by 2 because you're over counting. Similarly, you have to divide by 2 for each of the other colors for a total of 2 to the 6. So your total possibilities is 12 factorial over 2 to the 6. Now, let's count the number of ways for us to put, let's say, put one of each color on the odd slots and one of each color on the even slots, because that's essentially what we're doing. We're breaking up the two R's so that one of them goes to odd and one of them goes to even. So you have R, B, Y, G, O, P. You have to arrange these 6 on the slots 1, 3, 5, 7, 9, and 11. And you have to arrange another set of R, B, Y, G, O, P on slots 2, 4, 6, 8, 10, and 12. And how many ways are there to arrange these 6? 6 factorial. How many ways are there to arrange these 6? 6 factorial. So what we want is 6 factorial times 6 factorial. And this is our answer. All we have to do is simplify it. So let me actually expand out all of these. So in the numerator, you get 6 times 5 times 4 times 3 times 2 times 1. I'm not going to write times 1 because it's redundant. Times 6 times 5 times 4 times 3 times 2 times 1. Denominator, you have 12 times 11 times 10 times 9 times 8 times 7, 7 times 6 times 5 times 4 times 3 times 2 times 1 times 1 over 2 to the 6. And actually what I can do is I can move this 2 to the 6 over to the numerator. Now a bunch of stuff cancels out. 6, 5, 4, 3, 2 cancel out with this. Let's cancel out a 6 and a 2 with this one. A 5 and one of these 2s, I'm going to change this to 2 to the power 5 with a 10. The 3 and the 6, no, I already canceled out the 6. So the 3 turns this into a 3 as well. You can cancel out this 4 with an 8 to make a 2. You can cancel out 2 to the 5 with a 2 to make 2 to the 4 over 1. You're left with 2 to the 4 over 11 times 3 times 7. This cannot be simplified anymore. So 2 to the 4 is 16, 11 times 3 times 7 is 231. So your final answer is 16 over 231. So your sum is 247. And we are done. Thanks for watching, and I will see you next time.